So good morning, everyone. We are Group 24. My name is Adarsh Binu, and presenting with me are my teammates Pranav, Sudhir, and Sunil. So we are excited to present our project Sentinelx, an AI-powered multi-cloud and endpoint security system. So before before we dive into what Sentinelx is, let us understand what the is the critical problem it is trying to solve. Organizations rapidly migrate to cloud native architectures. Their infrastructure becomes decentralized when they do so. So, a modern company might host databases on AWS, web applications on GCP, and legacy workloads on Linux virtual machines. This creates what we call a multi cloud blind spot. Because logs are fragmented and across all these systems, security operation centers, SOCs, suffer from something called alert fatigue. So traditional technology tools rely on static rules, which generates thousands of low-level alerts daily. So the true critical attacks are often buried under a mountain of false positives. And traditional SIEM tools are just too prohibitively expensive and complex for most teams to manage. So, to solve this, we built Sentinelx, a unified AI-driven fragmented tooling with a single authoritative security intelligence layer. So, as we can see, the platform is built on three core pillars. So, first, we have unified detection. Sentinelx bridges a gap by providing continuous monitoring across AWS, GCP, and Linux endpoints, bringing all of that data into a centralized interface. So second, we have rapid response. We do not just overwhelm the administrators with raw logs, but we use real-time incident correlation and intelligent alerting to ensure that only high fidelity actionable that we surface high fidelity actionable threats into analysis. Third, we have continuous compliance. Sentinelx provides automatic auditing to ensure that your cloud configurations remain within uh, remain within strict security policies continuously rather than relying on periodic manual checks. Okay.
Room of Sentinelx, our architecture is designed for one thing, scalability. As you can see in the slide, they have built this on a decoupled microservice foundation that bridges the gap between cloud native logging and deep endpoint monitoring. Our front end is built with React and Vite, utilizing Land for state management. But the real magic is the real-time experience. We use WebSockets via socket.io to ensure that when a threat is detected, it appears on the dashboard in a sub-second, no refreshing required. Powering the logic is a Next.js backend, an enterprise-grade TypeScript framework that handles our API gateway and evaluation engine. For persistence, we rely on Postgres SQL 15. This allows us to maintain a strictly normalized multi-tenant schema where every event, alert, and incident is securely isolated by organization ID. Finally, the data ingestion happens at two levels. On the server side, we have our lightweight Python agent. We chose Python for its universal Linux compatibility. It uses native OS hooks and psutil to monitor process anomalies and file integrity in real time, communicating back to our Next.js API via cryptographically signed JWTs over HTTPS. Now, let's talk about where Sentinelx actually lives. While our project report details our cloud agnostic vision, our primary infrastructure is built on the AWS cloud backbone, as shown in the slide. We have strategically selected four core AWS services to ensure our SaaS is both hardened and durable. First, Amazon EC2 and VPC. Our application runs on scalable EC2 virtual machines. Crucially, These are isolated inside a hardened Amazon virtual private cloud. We utilize strict security groups to ensure the external attack surface is minimized to the absolute smallest possible footprint. Amazon EBS. For data persistence, every EC2 instance is backed by a 30 GB of Amazon EBS storage. This gives us the high performance block storage needed for rapid log processing while ensuring data isn't lost if an instance is rebooted. AWS CloudTrail. This is our primary eye in the sky for cloud security. Our cloud integration service runs on a polling daemon that requires the CloudTrail API every 3 minutes. We extract logs for critical events like S3 bucket deletions or IAM role assumptions and map them directly into our severity engine. By leveraging these AWS managed services, Sentinelx provides a native high availability environment that can handle the massive log volumes required for modern enterprise security.
Coming to generative AI SOC analyst, our project is designed to reduce alert fatigue and help security team respond faster to real threats. One of the core innovation in the project is the generative AI SOC analyst. Traditionally, security operations centers received thousands of alerts every day. Most of them were low priority, repetitive, or positive or false positives. Analysts waste a huge amount of time manually reviewing these logs before identifying an actual attack. To solve this problem, Sentinel-X integrates Google Vertex AI using the Gemini API directly into the backend threat analysis pipeline. The workflow starts with the ingestion. Raw JSON attacks vectors and security telemetry are streamed directly into the real-time from multiple sources such as AWS APIs and Linux endpoints. Uh, After this, the evaluation process comes. Every incoming event is passed through Gemini, which acts like an intelligent tier 1 threat security analyst. The AI evaluates whether the activity is malicious, calculates a confidence score, and then generates a human readable explanation describing why the activity is suspicious. Finally, during the alerting stage, one high confidence threats are surfaced to analysts. This significantly reduces noise and helps security teams focus only on actionable incidents instead of thousands of irrelevant alerts. In simple terms, Sentinel-X uses generative AI not just for chat or automation, but as intelligent cybersecurity decision-making lawyer. Now, let's move on to next slide. Okay. Now, coming to correlation engine. This is the one of the major component of Sentinel-X. In cybersecurity environment, one real attack usually generates many separate alerts across different systems. For example, an attacker might perform suspicious AWS API calls, modify sensitive Linux files, and access S3 buckets abnormally, all within a very short period of time. Most monitoring tools treat these unrelated events, which creates alerts storm and overwhelms the analysts. Our correlation engine solved this by intelligently grouping related anomalies using a single actionable incident ticket. Instead of showing analysts dozen of disconnected alerts, our system reconstruct the complete stacked narrative. This is extremely important because the context is critical in cybersecurity. Analysts need to understand not only what happened, but how different things are or activities are connected. For example, if a suspicious CloudTrail login is followed by abnormal S3 access and endpoint level file tampering, our system Sentinel-X correlates all of this together into one incident. This reduces investigation time, improves situational awareness, and allow analysts to respond much faster. Now coming to deep Linux endpoint visibility. This is the third key feature of Sentinel-X. It is a deep Linux endpoint visibility through our custom Python-based monitoring agent. The agent runs continuously on Linux hosts and provides real-time telemetry across the entire threat surface. The first capability of the agent is file monitoring. The agent detects unauthorized modification to important system files, binaries, and configuration files. This helps identify malware activities, persistent mechanisms, or privilege escalation attempts. The second capability is network binding monitoring. The agent monitors suspicious process to port bindings that may indicate reverse sales, backdoors, or unauthorized listeners running on the machine. Another important feature is cloud level S3 event correlation. Sentinelx bridges host level telemetry with cloud telemetry. For example, if a compromised endpoint suddenly accesses sensitive S3 buckets, the platform correlates both events together automatically. Finally, we integrate deeply with AWS CloudTrail. Every privileged API call made with AWS is captured and analyzed for anonymous behavior pattern. This gives organization visibility into cloud level attacks such as credential misuse, privilege escalation, or unauthorized resources. Overall, the Sentinel-X combines endpoint monitoring, cloud telemetry, AI-driven threat analysis, and intelligent correlation into one single unified security platform.
My name is Pranav, and I'm going to continue with the presentation. So let me start with the real world impact and future roadmap. So basically, the big idea about it is like, explain the traditional top tier security systems, which are incredibly complex and incredibly expensive, meaning only massive corporations can afford them. But the sentimental changes the game by making that enterprise grade protection accessible to everyone. Unified visibility. You're solving the fragmentation problem. Instead of a security team juggling 10 different tools to look at different clouds and endpoints, everything feeds into one single cohesive dashboard. AI driven precision. Explain the law like the alert fatigue. In the real world security systems, there are thousands of meaningless alerts a day, and analysts gets burned out. So we're using Gemini AI to filter out the noise so humans only deal with the actual critical threats built to scale. Because it's serverless and cloud native, it's not clunky piece of hardware. It's lightweight, scales up instantly as a company grows. That's like so. The next slide is about the future scope, enhancement, and evolution concept. So yeah. So what is passive to active? Like automated remediation. So it's like detecting a threat, sending an email, wherein the system will automatically isolate or neutralize the threat the second it's found, drastically cutting down the reaction time. The second concept we can explain here is like the behavioral versus rule-based ML. Like the traditional security looks for non-signatures like non-viruses, but in Sentinel it uses ML, machine learning, to understand what normal looks like for a specific user or host. If something acts weird, even if it is a brand new, never before seen zero-day attack, the system catches it. So the concept three is modern infrastructure, which is Kubernetes and multi-cloud. So you are acknowledging that the world runs on a modern architecture by expanding to the Kubernetes containers and multiple clouds like Azure, GCP. We're securing the actual environment companies use today, not just an old school servers. Next slide. So this slide is talking about the global purpose concept, wherein cybersecurity is not longer just an IT problem. It is like a global critical infrastructure requirement. SDG connection. So by aligning with the UN SDGs 9 and 16, you are explaining the protecting digital systems, which is essential for the global peace, strong institutions, and the safe innovation. You aren't just building an app; you are protecting modern security foundation. The roadmap here is like there's a high level impact back down to the technical reality, reminding them the immediate next steps like automated remediation, ML baselining, are how you achieve this global security goal. That's like here we come with the conclusion part. We conclude here by saying that we elevate a pitch summary wherein you want to leave them with three distinct pillars of why Sentinel works. Like pillar one states that we reiterate the single pane of glass concept to kill the fragmented tooling problem. Pillar two, remind them of the brain of the operation, like the Google Vertex AI, which is doing heavy lifting to find the needle in the haystack. And the last pillar is accessible and on the scalability. It's cloud native, means it's highly robust but still cost efficient for the organization to handle. Thank you.
So this is our project, Sentinel-X. Here you can see the live event stream has been collected from AWS. Here user have to put their AWS credentials, SS key and secret key and their zone, and then they will be able to connect. So after connecting, they will be able to see the live stream of the logs from the AWS. So currently you can see this is I am user named others has performed a lookup event on unknown And here on the event page, we can see all of our logs, and like, yeah, these are our high severity logs. And we'll get alert. If the severity is high, then we'll get the alert in the dashboard. And that alert will be correlated here in the incident page. So here we'll be able to manage these things, and then we'll mark them as result. So currently, we can add rules. We can define the rules, which will be captured by our AI, and that will check against this rule to detect whether certain activity is malicious or not. So CSS essential login. You know, login. Okay. Here we can disable it also this rule. Now coming to the infrastructure part. So this is our agent. Like whenever users create a virtual machine on any AWS or Google Cloud anywhere, they can deploy our Python-based agent. This agent will link their account to their account to the agent, and they will be able to send the logs from the EC2 instance. The logs will be it will collect logs related to file monitoring, network monitoring, and process monitoring. So currently, I have one connected agents on my EC2 instance. So this was sending some logs earlier. You can invite another just their organization. I'll invite myself. Okay. Okay, this is the invitation I have received from the Sentinelx. Now here is the AI analytics. So over time, like over time, the AI will analyze all of the logs, and then it will give its judgment and its score. So which you can see here, like behavioral deviation in this, like how whether the privilege escalation, the risk of privilege escalation is normal. So currently there is no such malicious activities being performed.